Hello, welcome to our 6th lesson on SPSS. In the last lesson, we went through how to perform the one sample t-test in SPSS and how to interpret the result. In this lesson, we are going to look at the two sample t-test or the independent sample t-test. We will look at when to use it and some examples. We will look at some assumptions of the independent sample t-test, check some of these assumptions in SPSS, then we'll go ahead to perform the independent sample t-test in SPSS. And finally, we'll look at how to interpret the result as we've been doing or as we did in the previous lesson. So let's start. When do we use the independent sample t-test? Or in what cases do we use the independent sample t-test? This test is used to compare the means or averages of two independent groups to see if there's a statistically significant difference between them. So we want to find out whether there's a significant difference between two independent groups based on their means or their averages. So this test also compares means. In statistics, means or averages is very important. So all the t-tests compare means or averages. And that is what we are going to do in this lesson. But here we are comparing the means between two independent groups. So let's take some examples for better understanding. We are going to take our examples from different fields. So let's take our first example from the field of science. A biologist wants to compare the growth rate of plants using two different fertilizers. Now what the biologist will do is that he already has the two different types of fertilizers. What he will do is that he will get some plants, let's say 100 plants. Then he will divide these plants into two independent groups. Then apply the first type of fertilizer to the group 1 and apply the second type of fertilizer to the group 2. Then in some weeks time or in a month time, you check the growth rate of the plant, let's say in centimeters. Then let's say you applied fertilizer A. Here we are not using specific names. Let's just call the first type of fertilizer fertilizer A. And let's say you apply the fertilizer A to 50 plants. So that is the first group of plants. Then fertilizer B to other 50 plants. So that is group B. Within these two groups, we find the mean growth rate to see if there's a significant difference between the mean growth rates using the two fertilizers. So you see the one which is more effective. Let's take the next example in the field of engineering. So a civil engineer wants to compare the strength of two cement types. Here the engineer can decide to pick 20 bags of the first type of cement, and that will be group 1. Then 20 bags of the second type of cement, that will be group 2. After that, you can compare their means to see the one which is stronger. Next example, this is in the field of medicine. A clinical trial tests the effectiveness of drug A and drug B in lowering blood pressure. So here too we have group 1 and group 2. We test the effectiveness to see the one which is more effective. In the field of education, a teacher wants to determine whether male and female students perform differently in mathematics. So group 1 is male and group 2 is female. Let's take the last example in the field of business. A marketing team wants to know if online shoppers spend more than in-store shoppers. Online shoppers group 1, in-store shoppers group 2. So you compare their mean spending to see where we get more money from. Now we've looked at examples from different fields. I decided to pick examples from different fields so that we know how important SPSS or this independent sample t-test can be to different fields. So let's proceed to look at the assumptions of the independent sample t-test. The first assumption is that your independent variable should consist of two categorical independent groups. So it is called the independent sample t-test because we have two independent groups which are categorical variables. So let's take an example here. We have gender and scores. So the independent group is what? The independent variable here is the gender. And all this assumption is saying is that the variable gender should consist of only two independent groups. We can't have more than two groups in the independent variable, which is gender. Here we have only two groups in the gender, which is male and female. We have only two groups. We cannot have more than two groups. If we have more than two groups, then we can't use the independent sample t-test. We have to use ANOVA. Let's look at the next assumption. The next assumption is that there should be one dependent variable measured on a continuous scale. So here the scores here is the dependent variable which is measured on a continuous scale. So that is for the second assumption as well. Let's go to the next assumption. Independent observation between and within groups. Independent observation between groups means that one observation here, one test score in one of the groups, let's say males, should not affect the test score or the outcome of a test score in the other group. So that is the meaning of independent observations between groups. Then within groups, independent observations within groups means that in each of the groups, let's say in group 1, which is the male, the test score of one male should not affect the test score of other male. And when we come to the other group 2, one female score should not affect or should not be dependent on the other female score. That is the meaning of independent observation within groups as well. Let's move to the next assumption. The dependent variable is normally distributed within the two groups. So this is the dependent variable here, scores, and this assumption is saying that it should be normally distributed within the two groups. So we have two groups, males and females. Within the male category, the scores should be normally distributed, and within the female too, from this one out to the last one, they should also be normally distributed, and data sets should be normally distributed within each of these two groups. And the last assumptions, the groups have equal variances or must have equal variances. That is termed as homogeneity of variances. So the average spread within these scores for the male is assumed to be the same as the spread for the female. For this assumption, we don't have to check it ourselves. When we perform the test, SPSS will tell us whether this assumption is violated or it is not violated, so that we know how to present our result. So now that we've looked at all the assumptions, let's take one of the examples and look at how to perform it in SPSS. So we are going to take this example in the engineering field, where the civil engineer wants to compare the strength of two types of cement. Here the first type of cement has been named cement A and the second type cement B. So you compare the mean of each one of these types of cement, and we try to find out whether there's a statistically significant difference between the means or not. So this data set is in Excel, Microsoft Excel. But in SPSS, to perform the two sample t-test or the independent sample t-test, this is not how our data should be arranged. These two groups, the numbers we see from the continuous variable, it should be in one column as we see here. Then the group, this example we have here is for gender and scores. So here the groups will be the cement type, and the strength of the cements will be the continuous variable as we have our scores here. So this is how we need to arrange or present our data in SPSS to be able to do the two sample t-test. So I'm going to rearrange this data in Excel so that when I open the SPSS, I can just copy and paste, and we proceed to do our analysis. I hope you get it. So I'm going to rearrange this data to the format that is used in SPSS. So here, the way we have 1 and 2, 1 is for male and 2 is for female. Here too, we can assign 1 for cement type 1 and 2 for cement type 2. So let's do that. I'm going to type cement type here, cement type, and here will be these numbers that we see here refers to the strength of the different types of cement. So I'm going to type strength here, and I'll copy the first group. I'll copy the strength for the first group here. I'll copy and paste it here. So that is cement type 1. So 1. So all this here is for cement type 1. So I'm going to assign 1 to all of these. I'll copy the next one and continue from here, paste it. So now they are all in one column, the strength, they are all in one column. To the second, then I'll assign 2 to the second group. So 2, 2, I'll fill for the remaining up to the last one. Okay, so this is how it's going to be in SPSS so that we can proceed to do our analysis. So I'm going to open my SPSS. So there's a blank SPSS file. Let's go to the variable view. I'm going to type the variable name cement type. So if I want a space between the cement type, I can decide to bring underscore since SPSS does not allow for space. I'll type the type here and click on enter. Then the second one will be the strength. Our second variable, which is the continuous variable, should be the strength. Click on enter. This is a categorical variable, so we can decide to encode the cement types. So let's say cement type 1 is diamond cement, so let's name it diamond. We have diamond cement, so I'm going to type diamond. Click on add. Then 2, let's say 2 is GASM, so type GASM. Click on add, and I'll click on OK. So when I go to the data view, I see these two variables here, cement type, and strength. So I'm going to copy the data from Excel and come and paste it here. I've copied it. I'll go to SPSS and paste it so you can see. So you can see the diamond and the GASM. So the first 20 is diamond, so each group contains 20, and the strength 2, I'll go and copy it from there, from the first one to the end. I'll copy it, go to SPSS, first row, paste. So now we have our data here in SPSS. We can proceed to do our analysis. But before that, we need to check one assumption, which is the normality. So how do we check the assumption of normality for a 2-sample t-test? I'll go to analyze descriptive statistics. This time I will not use the frequencies. If it was 1-sample t-test, I could have used the frequencies, but here I need to use the explore. Now move my independent variable into the dependent list, which is the strength. Then I'll move this one, the categories or the cement types, into the factor list. Click on plots, and I'll check histogram and normality plot with test. That is how we check normality for 2-sample t-test, to see whether the data is normally distributed within each of the groups. So we have the results here. There are a lot of tables here and diagrams. We have the histogram, and they did it for the different cement types. So there's the histogram for the diamond cement, histogram for the GASM cement. Then we have this one too, QQ plot. There's a way to know if it's normally distributed in all of these diagrams. For the QQ plot, if you want to know, you have to check whether the points or the dots here are close to the line. So this shows that it's normally distributed. This one to all the points fall close to the line. It shows that it's normally distributed for the GASM. Here for the diamond to the same. All these are visual inspection. But the easiest way is to use this table, test of normality, using the Kolmogorov-Smirnov test or the Shapiro-Wilk test. For this test, let's go with this one. There are instances where we use this one, but I will not explain that for now. Let's go with this one. Let's check the significance level to see whether the data set within each of the groups is normally distributed. So we check the diamond. So here, if the p-value is greater than 0.05, which is 5%, the alpha level, it means our data is normally distributed. So this one is 0.18, 18.9%, which is greater than 5%. It means our data is normally distributed. Because for this test, if you are going to state the hypothesis, the null hypothesis will state that the data is normally distributed, or it doesn't deviate from the normal distribution. So the p-value here is greater than the 0.05, meaning we will not reject the null hypothesis, which says that they are normally distributed. This one too is 0.2, 20%, meaning it doesn't deviate from the normal distribution. So we can see that the data set within each of the groups is normally distributed. So now we can proceed to perform our 2-sample t-test and interpret our results. So let's do that. How do we perform the 2-sample t-test? Go to analyze. This one we are comparing means, so you go to compare means, just as we did for the 1-sample t-test. Choose independent sample t-test. Click on it. In the text variable box, you move your dependent variable there, and the cement type is the grouping variable. So you have 2 groups. So when you put it there, you see this question marks. Click on define groups. It already has this one, the values of 1 and 2. If we assign different values, let's say 0 and 1, we will specify that here. So group 1 in our group is 1 and group 2 is 2. So just click on continue. You see that it appears here. Now we can proceed to click on OK to get the results for our 2-sample t-test and interpret our results. So I'll click on OK, and this is the results. So the first table here gives us the descriptive statistics for the 2 groups. So you have the sample size for the 2 groups, the mean of each one, the standard deviation, the standard error for each one of them. But the table that contains our result is this one, p-value from here to the side. We have 2 here. So when do we go for any of these? Here they are the same value, so it will not really affect if you don't know, but we have to know when to use this and when to use this as well. So one of the assumptions for this test is equality of variances, and SPSS test for this one, we don't have to do it ourselves. When we perform the 2-sample t-test, SPSS does it automatically using the Levene's test for equality of variances. So if it's violated, that's when you go to this second row. But if that assumption is not violated, we go with this first row. We take the significance level from this first row. How do we know whether it's violated or not? If this one is greater than 0.05, it means we do not reject the null hypothesis, and the null hypothesis states that the variances are equal, or there's no difference between the variance. So that assumption is not violated. If this one was significant, meaning if it was less than 0.05, that would have meant that this assumption is violated, and you go with this second row, pick the p-value there to make our decision. But here it's not violated, so we go with the first one, and this p-value shows that there's a statistically significant difference between the means of the two groups. So one cement is probably stronger than the other. So let's look at how to report the T value to is here. We can compare it to the critical T. Here they are the same for both rows, but we are going with this one since this assumption is not violated. Equal variances is assumed, so that's what we are going to use. Let's look at how to report so that will bring this lesson to an end. I did not want this lesson to become too lengthy, but it seems it has become lengthy, so let's look at how to report in APA star and bring this lesson to an end. But let's state the hypothesis for this test. The null hypothesis, the H naught, says that there is no statistical significant difference between the means of the two groups, and the alternative says there is a statistically significant difference between the means of the two groups. With the result that we've seen, how do we conclude? So this is our conclusion, or how we report in APA style. An independent sample t-test was conducted to compare the compressive strength of diamond and gypsum cement. There was a significant difference in means between the two groups. Calculated T here, the p-value which shows a significant difference. The mean strength for diamond cement, and you report the mean and the standard deviation, was significantly higher than that of gypsum cement. You report the mean and the standard deviation as well. The mean difference was 4.55. The 95 confidence interval for the difference too was this. So that is how we report. This brings us to the end of this lesson. Thank you very much for watching, and see you in the next lesson.